Hi, I'm from Group 4, J4CEEM1103J, and my name is Wan Afif Haziq bin Wan Ahmad Shaifuddin. So this is my group member.
Hi, my name is Wan Azhad bin Aidi.
Hi, my name is Nur Ali Soleha binti Mayatim. In this workshop, we are learning the metal casting process, which the metal is melted and poured to form into a specific shape. This process is widely used in manufacturing, but it also involves a significant safety risk.
So during casting metal, extreme heat, fumes and dust can be dangerous. That's why using proper PPE, which is personal protective equipment, such as heat resistant glove, face shield and aprons is essential. Good ventilation is also important to reduce exposure to harmful fumes.
Sustainability is another key aspect. In metal casting, we can reduce waste by recycling molding sand and controlling energy usage during the melting process. These practices not only help the environment, but also make the workshop more efficient.
First, before we enter the workshop, we need to scan the QR code for record purpose. After that, the shuttle need to be opened. Don't forget to make sure the first aid kit are provided in case of any accident happen during casting.
This is what safety and sustainability practice in casting. In our workshop, for safety reason, all students need to personal protective equipment. This cover up all of our body because this can avoid high heat molten aluminium. First and foremost, we need to wear a face shield to cover up our face. The second thing is we need to wear an apron to cover our body. The third is wear the glove to avoid our hands being burned. And last but not least, we need to wear our safety boots because it's harder than steel. That's it.
Make sure to switch off the furnace and light when not in use. This practice shows that a safe, efficient and sustainability working to students and staff.
For sustainability, the leftover metal will be recycled for another use by melting and molding again. For the sand, it will be reused and reclamation. Several solutions to improve safety and sustainability in the casting workshop. First, schedule furnace maintenance. Our first solution is to introduce regular furnace maintenance. Please follow the Factories and Machinery Act 1967, which require machine to be safe and well maintained by checking the furnace temperature, insulation and structure every month. We can reduce energy loss and prevent overheating. Solution 2. Install local exhaust ventilation, which is LEV. For the second solution, we propose installing the local exhaust ventilation system near the furnace area. This requires based on OSHA 1994, which requires employees to provide clean and safe air quality. LED will help to reduce fumes, smokes, and heat, creating a safer environment for all of us. For solution 3, the third solution focuses on sustainability, which using ISO 14001 environmental management system, we recommended improving the sand reclamation process. This includes sieving, drying, and reusing the sand to reduce waste and disposal and lower material costs. For solution 4 is provide proper pouring training to reduce molten metal splashes. This is follow MEM160 Occupational Safety and Health Management System, which emphasize hazard control and safety training. We also suggest improving the pouring basis design to reduce turbulence.
In improving safety and sustainability in the casting workshop, we must balance 3 major factors. Number 1, cost. Number 2, safety. And the last one, environmental impact. Sometimes these factors conflict and we must make responsible decisions. Number 1, cost versus safety. Installing proper safety systems such as better ventilation, heat-resistant PPE, and regular furnace maintenance increases cost. However, referring to the Occupational Safety and Health Act 1994 (OSHA) and Factories and Machinery Act 1967, these safety features are compulsory to protect students from burns, fumes, and heat exposure. Even though safer equipment is more expensive, it prevents accidents such as molten metal splashes during pouring, which is a common risk based on our casting process in the lab sheet. Number 2, cost versus environmental sustainability. Recycling sand and aluminum scrap reduces environmental impact but requires additional equipment and time. For example, the sand used in the molding process must be reconditioned before use. Aluminum screws, risers, and defect casting must be remelted. While reconditioning sand and recycling metal involve extra work, it aligns with ISO 14001 Environmental Management System, which promotes resources efficiency and waste reduction. Number 3, safety versus production efficiency. Proper safety practice may slow down production. For example, students must wait for metal to fully melt, take almost 2 hours. They must follow careful steps in ramming, pattern removal, and pouring. This lower step reduces efficiency but ensure high quality casting and avoid defects or injuries from rushing.
In conclusion, our case study highlights that the casting workshop has good practice in place, but improvements are still needed to ensure full safety and sustainability. We identify issues such as heat hazard from molten aluminium, fume exposure during melting, sand and material wastage, energy consumption of furnace, risk of burns or injuries during ramming and pouring.